Hello, everyone, and thank you for joining us today. My name is Brittany Bodane, and I'm excited to be here today to show you how to create dynamic models from scanned maps in Surfer. Today, we'll go over how to georeference an image, crop an image, digitize contours, create a raster grid from our digitized contours, and how to view our scanned image and digitized contours in 3D. After the discussion of each topic, I will stop for a few minutes to answer any questions. You can send your questions to the webinar host via the questions box at any time. The questions box is on the webinar control panel underneath the audio section. Type in your question and it will be sent to the webinar host, who will either answer it or forward it to me. Please feel free to send in all of your questions. There are quite a few of us in the webinar today, so if we don't have time to get to all of your questions, we will answer them via email once the webinar is complete. This webinar is also being recorded. Later this week, we'll post the recording along with the data used in the webinar. We'll send all of you a link when it's posted so you can test these examples out yourself. So let's get started. First, we're going to take a look at some hand-drawn bathymetry contours that were scanned in as an image file. This image could be anything. It could be a scanned image from an old report, archive, a map created in another software package, or something drawn in the field. To import my image, I'll start by clicking Home, New Map, Base. Select my image and I'll click Open. So our image is opened and we can see the axes just have these kind of arbitrary numbers on here. These are actually page units. We want to apply real-world coordinates to this image, but before we do that, I want to crop off some of the white space and this text that's been added on here. So we just have our contour image. You can crop an image in Surfer by selecting the base layer the image is contained in and clicking Features, Image, Crop. You can just drag the handlebars in. And when finished, press Enter on the keyboard. So you'll notice the image is cropped, but our map limits didn't shrink. If you were expecting the map limits to shrink, or you'd like them to shrink for your image, all we need to do is update the map limits. To do that, in the Contents, select the map object, and in the Properties, click the Limits tab. And I'll just check Use Data Limits. Although these fields are completely editable, checking Use Data Limits does what we want it to. It shrinks it down to the actual limits of my newly cropped image. So now that we've removed everything via cropping, let's georeference our image and apply some real-world coordinates to our image. I'll click the base layer again in the Contents. And on the General tab in the Properties, we see a Georeference Image button. The Georeference Image dialog shows the image, of course, and down below we have our where we'll enter our coordinates to georeference. Surfer gets us started by automatically adding our control points to the four corners of our image, and that might work just fine for you. I tend to think it's a lot easier to have control points for noticeable spots in our image. For example, in our image, you'll see the control points I'm going to use are highlighted in yellow. And particularly for this image, that white space is not something I would have a coordinate for because it's not even actually part of the image I'm trying to georeference. So control points can be deleted by clicking Delete Mode up in the ribbon of this dialog and clicking on a point, or we can get rid of them quickly by pressing Control A while clicking down in our coordinates area and then delete on our keyboard. Now I can go ahead and add my own control points. I'll use the Add mode to start adding them. So I can just zoom in on my mouse, or there are, of course, zooming tools up here. And then I'll click, and my point is added at the bottom. The source X and source Y are the pixel units of the image, your pixel coordinates of the image. I'm just going to keep clicking my points, and we'll add my coordinates at the end. I can use the hand to pan, so I don't have to zoom out each time, or just press the scroll bar down like you would in the plot window to pan. And there is the nice option to click View Image and zoom us back out so we can see everything. So now that I've clicked all my points, I'm going to go ahead and start adding my target X and Y. These are my real world coordinates. These could be lat long, UTM, state plane, or it could even be a local system if your organization works in more units that are just a internal reference. It doesn't have to be a set coordinate system like lat long, World Geodetic System 1984, or UTM, or something like that. If you weren't given coordinates for your image, or you don't know any coordinates for your image, a nifty trick is to use Google Earth. You can zoom in to where you're working, and then use the pin to copy and paste the coordinates from Google Earth to Surfer. That's one way I like to do it when I don't have my own coordinates for something. So I have my coordinates on another page off screen here, so I'm going to quickly copy paste these in. And I'm just pressing Control C to copy and Control V to paste. So I haven't yet talked about this error column. As soon as I click out of this field, Surfer will calculate the error of my points. And what that means is it's getting a good look at what the pixel units are compared to the points I put in, and how true that seems across the image. You can actually get a good idea of that. And the error is really helpful just to help you know that you might not have placed your point in the best spot. But also something our support team sees a lot is users that are confused about georeferencing their image, and really all that's happened is they've just made a typo. So I'll click outside of this. We can see my error is showing up here. And we want this to be as close to 0 as possible. So these numbers are totally fine. I'm very comfortable with this amount of error. We can see, for example, a common issue we'll see when a user has a typo is they're just simply missing a digit. So if we get rid of a digit, we can see how our error really jumped up here. If you are trying to fix your error and you didn't make a typo, you just need to move your point around, you can use the select mode tool to click and drag your point. So it's green when it's selected, and then I can just move it down a little bit if I want, or where I think it should be. And then some other tools I want to point out up in this ribbon area is you do have the ability to save your control points. If you georeference a lot of the same images and you use the same control points, you can save these, and then next time you need to use them, load them with the Load Points button. And then the last thing I want to say about georeferencing is how many points are required to georeference. 3 points are required, but I typically like to use more. For example, we used 4 here. The more, the better, but also you don't need to do 10 to get a good georeference. 4 for this is going to be fine. Another important thing to keep in mind is your georeferencing points need to be spread throughout your image. If we did all of our points clustered on the tip here, our image would be very skewed when we apply our units to, or apply our new coordinates to our image. So it's important to spread it out across here. So what we've done here will be perfect. So now we've added these coordinates in, but as we can see, our map hasn't updated yet. we update the coordinates by clicking Update Map. So I'll go ahead and update our map now. Surfer right now is telling us that these new coordinates we're applying are going to significantly change the limits of our map, and that's perfect. That is exactly what we wanted to do. So I'm going to click Yes. And now Surfer is saying that our new limits have changed the scale of the map so much that Surfer is going to create a new default scale for us. It's also letting you know that if you don't like the scale it's given, you can change that on the Scale tab in the Properties. So I'll click OK. And now we can just exit out of this dialog. We've applied our coordinates. So as we can see here, our axes are looking good. The next thing that's important to do is to add a coordinate system to our map object in our layer. Applying a coordinate system might sound a little bit redundant because it kind of feels like we just did that with georeferencing, but really all we've done with georeferencing is tell Surfer what numbers these coordinates should be. Surfer has no idea if these numbers are state plane, if they're UTM, if they're lat long. So if we tell Surfer what these values are, we have a lot more that we can work with in Surfer. For example, Surfer can have many, many layers in one map object, meaning this is our map object, and we could have many other map types listed under here. Each of those map types as our layers could be a different coordinate system, and Surfer will convert them on the fly to whatever coordinate system is set as the map object. So it allows you to easily overlay your maps without worrying about all of your data being in the same exact coordinate system. So we'll go ahead and set that now. First, we'll apply our target coordinate system to the map object, and that again is the coordinate system that Surfer will convert all of our layers to, were we to have layers with different coordinate systems. So I'll select the map object in the contents. In the Properties window on the Coordinate System tab, I'll click Change. So you do have to know your coordinate system. You can get to the coordinate systems by expanding these, or since you know what you're going for anyways, I like to use the search. I know I'm looking for 13N, so I'm just going to type that in and press Enter, and Surfer is going to limit everything we see to only the options that include 13N. So I'll click OK. Surfer is now telling us that we have added the coordinate system to the map object, but our layer doesn't have a coordinate system, so Surfer can't really do much with that layer or the map coordinate system until it knows what coordinate system the layer is in. So I'll click OK. And our layer is going to be the same coordinate system as our map object. So I'm going to click Assign Now in the coordinate system dialog of the map. And this assigns the coordinate system of the map object to all of your layers. So if I had several layers in here that were all the same coordinate system, I could click Assign Now and assign it to all of my layers rather than clicking each individual layer, clicking the coordinate system and tab, clicking Set, finding it again. It just automatically applies it. And here you can see I've selected the base layer and the coordinate system tab, and we can see the coordinate system's applied. Coordinate system is not required, but it can save you a headache down the road. So I wanted to show you how to do that. Next, we'll take a look at digitizing our contours, but I wanted to see if we had any questions so far. Okay, so far I see we have one question, and it is, if you made a mistake georeferencing after you close the dialog, do you have to start georeferencing all over again? Great question. Thank you so much for sending that in. No, you do not have to start over. You can just select the layer, click the General tab again, and click Georeference Image, and you can just edit this, and it has everything in. And even since we have applied our coordinate system, Surfer is able to tell us our unit here is actually meters. So you are good to continue changing this as you need to. Okay, and we've got another question. If we wanted to use this image after digitizing the contours, is it possible to get rid of the gray in between the contours? And yes, it is. You can choose a color to set to transparent, select the layer with the image, and on the General tab in the Properties, check the box next to Set Transparent Color. Surfer by default starts us out with white, which actually takes care of a lot of the gray. This tolerance slider controls how much colors are affected by the transparent. At a certain point, it's just going to wipe away our whole image, setting the tolerance all the way up. But you can see you can find a pretty good level where we can get rid of it but still see our contours. It would also work nicely to get rid of this yellow. The yellow is a little bit harder to get rid of because it was like a marker used on a pen, kind of smudged a little bit, but that's okay. We can still take care of most of that. We could click this drop down and choose a yellow and try to set the tolerance, or I think it's a little bit easier to click custom colors and use the eyedropper. And here we can see the gray is back, but the yellow is gone. Right, and if you have any questions, feel free to send them in. I'll move right on to the digitizing portion. The first step to start digitizing in Surfer is to add an empty base map. We can do that by selecting our map object in the contents, clicking Home, Add to Map, Layer, Empty Base. I like to think of the empty base as a blank canvas. We click this and we have our base map in here. We can click the expand button, but there's nothing in it yet. You'll also notice that when I have this selected, we see the coordinate system tab. Surfer's gone ahead and automatically assigned this layer the same coordinate system as our map object. So that's one reason why setting the map object can be helpful. We already have a coordinate system set for this, which will make our life a little bit easier moving forward. The base map is where we will draw some polylines into to digitize these contours. When you select a base layer, we see this red, a base vector layer, excuse me, rather than the base raster. We see this red arrow because that means we can edit this layer. When it's selected, any of the tools we use on this Features tab will add these features we draw into this base layer. And we want that specifically because they'll be drawn with the coordinates we're using in this image. If we were to draw a polyline outside of this base layer, it would just be free floating and it would again be in our page units, which would be useless for digitizing our contours. We want the X and Y units of this image that we just georeferenced. So with my base layer selected, I'll click Features, Insert Polyline, and just zoom in on my image and just start clicking to draw. And I'll do this pretty quickly, but I imagine you might take a little better care. Once you get to the end, double click to stop drawing. And I won't make you watch me trace all these lines. If anyone was starting to worry, I'll just do these. And then, there we go. So now that I've drawn two polylines in here, I'll just press Escape on my keyboard to exit drawing mode. We can expand our base layer and we'll see both of the polylines have been added to it. We can add our Z level in one of two ways. So far, we just have the XY coordinates. We can see the XY coordinates of this line on the Coordinates tab. But to give this a depth or a Z value, we can click the Info tab and we can add a new attribute for our depth. So I'll click Add. We'll name our attribute name and change our attribute type to numeric and click OK. We now see this field down here, so we can go ahead and just type our depth. The other way of adding the Z value is to open the attribute table. You can open the attribute table by selecting the base layer and clicking Map Tools, Layer Tools, Open Attribute Table. When we open the attribute, you can see the field that we just made in the Properties Manager has been added here, and so is our value. So all we need to do is click in this field, and you can see the polyline selected in the contents as well as the plot window to make sure you have the right one selected. And then we can just go ahead and add the depth here. The attribute table is modal, so you can have this open while you work if you prefer to use the attribute table, maybe put it on a second monitor or something like that, so you can just have it open and do both at once. But you can do it in either location, whichever one is easiest for you. Once it's been added, we can just close the attribute table. You don't have to save anything. If you've noticed this save icon, that's to save the attribute table to a text file, which can be helpful as well. But we'll just close it and that information's been added. So like I said, I'm not gonna make you watch me digitize all of these. I did this earlier, so I'm just gonna add the file that I created earlier back into the map. And what I did earlier was trace all these polylines, and then when I was done, I turned off all of my visible objects except for my base layer. So for example, turn off all my visibility except for my base layer. And then I used File Export and chose to export it as a shape file. Any vector file format would work to export it to if you need to use just the vectors later on after you've digitized. So shapefile or DXF is another really great option. So that's all I did. I just exported it, and because we have a coordinate system assigned to our map object, my shapefile has that geospatial information saved. So it's another reason why it's great to assign your coordinate systems. You can export objects out of Surfer with that geospatial information. So I'm just going to turn our objects on here, and you might notice I'm highlighting all of them. I just used Shift when I clicked the first and last one, and then I held Control for this. You can actually now toggle visibility on and off of multiple objects in Surfer. It's new in this version and makes my life much easier. I hope you're all enjoying that new feature as well. Okay, so I'll add the shapefile that I just described creating to the map by selecting the map and clicking Home, Layer, and vector files such as the shape or DXF are opened as base maps. So click Open. Okay, so now we can see the complete file that's been digitized, just so we can take a look at what I did before we move on. I'll change our line properties so we can see a little bit better. And here we can see I did a pretty decent job tracing over my lines here. As I'm looking at it, I might notice that I didn't do the best job on this one. So I can actually select this polyline and click Features, Edit, Reshape. And I can just highlight these, delete them, hold Control, add a new point, and drag it up. Add another point so it's a little bit smoother. But the vectors are always reshapeable after you draw them. So that's looking a little bit better. Another tool you might use to make this go a little bit faster is using the smoothing tool. If you made kind of jagged lines, you can click Line Smoothing, and we can add nodes between our points here. So we have a polyline selected. This is one we're working on. If I click 2, we can see the points in the selection increases, and you can actually see the line smooth as you're working in this dialog. You don't have to click OK to see the changes. It's a little bit hard to see right now with our zoom level, but it's a very nice feature that you can change these options, see it in the plot window without clicking Apply or OK. It just updates, and you can cancel if you need to. So now that we have all of our lines digitized, the next step is to convert our polylines that we've drawn and digitized here to a grid. So for this is super easy to do. We'll click Grids, New Grid, Grid from Contours. The contour source can be selected from an open file. Since we have our shapefile open, I can click it. As soon as I've selected my file, Surfer prompts me for which attribute contains our z-value. And of course, we named that depth, so I'll click OK. You don't have to have the file open to use Grid from Contours. You can browse to your file without having a map open at all to create your grid. Now that we've loaded our contour source, we can keep filling out our dialog. You can use faults if you had faults. We don't have any, but again, with faults, you could select an open, if we had drawn our faults in an empty base map, kind of like we did to start with here, we could just select it without even saving the file, or if you had it in another vector file, again, you can browse. We'll leave that because we don't have any faults. Below is the output grid geometry. It's identical to the field you see in the standard grid data dialog that you use when gridding XYZ data. And what we see here is the limits of our data, which is editable. If you needed to expand to extrapolate your contours, you can change these to expand your limits, and Surfer can extrapolate. Or you can shrink these. Most of the time, these are the fields that people change. The spacing and number of nodes fields are tied, and they control the resolution of the grid. Right now we can see we have a spacing of about 11 in the X direction and the Y direction. The spacing field is always in the units of your data. We're working in meters, so what this means is there are about 11 meters between each node in the X direction and about 11 meters between each node in the Y direction. We can update this if we need to, and you'll see the number of nodes increases. If you prefer to update the number of nodes, that also works. You can see it changes here. We'll just leave ours at this resolution. Below in the options section, we have some different options than you see in the standard grid data dialog. And these are specific to gridding from contours. Well, the first is assign node data, and that is in the grid data dialog, so I spoke a little bit too soon there. I will explain this now, though. This helps your data from extrapolating. A lot of times when you're gridding from contours, you don't really want to extrapolate. You are just trying to replicate the contours you already have, but in a more usable format. So assigning data outside convex hull of data, you can imagine this as though you have hammered nails into a board. Each nail is a data point, and then wrap a rubber band around your data point nails, and what's inside that rubber band is the convex hull of data. Next, we have the option to close open contours. And this option, you can check this to automatically close contours. Excuse me. You can check this option to automatically close contour lines that end within a specified distance, the ends within. This closes them by adding intersection points for the contours to close using the ends within value. Contour lines will not close if it would result in crossed contours, because as we all know, contours do not cross. This is not how they are created. So below this, we have the partial contour cleanup. And you can check the partial contour cleanup to improve the performance around open contours that terminate in the interior of the map. It's especially near the edges of the map or when the contour lines indicate faulting. However, some input layers or files, the partial contour cleanup option will decrease performance in the resulting grid, and because of this, it is unchecked by default. And one important thing to keep in mind when you are gridding, either through the grid from contours dialog or the standard grid from data contour or standard grid data dialog, is that there are no hard and fast rules for gridding your data, and it does sometimes take some trial and error. So don't feel silly if you don't get the exact grid you wanted the first time around. It might take you a couple times of maybe changing your resolution by changing the spacing, but also playing around with your ends within area if you want to close the open contours or partial contour cleanup. So I'm going to leave all of our default settings here, and I'm happy with where my output grid is going to be saved and the name that it's going to be given. That's what the output grid field tells us. And at the bottom, I'm going to choose to add my grid as a layer to our existing map, and I would like it as a contour. One important thing to understand about what we're doing right now is by using grid from contours is we're creating a grid file. This grid file can be used as many times as you want in the same project. You can open it as any of these grid-based map types. So we're not just creating a contour map through this process. We're creating a grid file that you can use as a 3D surface or any of these options you'd like. So I'm going to stick with the contour and click OK. And GoToMeeting slows my computer down considerably, so we'll give Surfer a second here to process while the screen share is running. Normally this takes less than a second. Okay, so our contours have been added. You can see they look a little bit different, and again, this is here because we had that convex hull of data. If we imagine we wrapped a rubber band around here, the rubber band would cut across here. It's not going to tie itself in, it's just kind of creating a band around it. So we can make our contours match our existing contours by changing our settings to more closely match the contour settings of our original image. So I'll do that by selecting the contour layer, and in the properties on the levels tab, I'm going to change my minimum contour to 0 and the contour interval to 5. And then I'm going to change the color of my contour lines so we can get a better look. So now we can zoom in and we can really see how these lines are giving us the same contours we started out with. We want to compare just to the shape file I created by digitizing, and then we can compare the contours to the original image to really see how these different iterations of creating these contours really works. Okay, next we'll take a look at looking at all of our data in the 3D view. But before we do that, do we have any questions? Okay, we do have some questions coming in here. And the first question is, why are the polygons excluded? And yes, these should be probably changed to polygons to show Surfer that these are connected here. They are excluded on here, but it also could just be a function of the setting our settings here. We don't really know the exact settings we had here. So Surfer is also trying to emulate it. But we can go ahead and see here, select my, turn this off. And I'm just trying to select the polygon in this layer here. So we can convert this to a polygon. Features, change type, polyline to polygon. And then we can just grid again, and let's see what are differences here? So we'll select it from our open file. And we're going to leave all of our same options. And again, we'll wait through the slowdown the screen share causes here. Okay, perfect. Our grid's been created. And now we have the polygons. So good example of how you can quickly correct issues that you might see as you go through this. You notice you are missing some closed contours in the center. It's as easy as selecting those polylines, converting to a polygon, and just popping that file back in the Grid from Contours dialog. Thank you for your questions. Do we have any more so far? All right, not seeing any questions right now, but if you have any, please send them in. And for our last segment here, we'll talk about displaying our data in Surfer's 3D view. So to view data in Surfer's 3D view, we need an X, Y, and Z. You can view data that contains a Z value when it's loaded as a post map, as a base map, and of course, a grid file can be viewed in the 3D view. An aerial image isn't able to be added to the 3D view unless you have a surface to drape it over. We just created our surface by creating our grid. And I'm going to get rid of this one, actually, since we like this one better, I think. So we can have that overlaid on our grid in the 3D view. So we'll take a look at that now. You can open the 3D view by clicking the map, and in the properties on the view tab, click 3D view. The 3D view shows what we have displayed in the contents window. So right now we're seeing our 3D surface, our contours, and our image kind of all melded into one. We can control the surfaces we're seeing in the 3D view by clicking the objects underneath surfaces. Any grids would be listed here. And we can turn this off and just view the contours from the grid, turn it back on. We can go back over to the plot window and our image is actually turned off, so we're not going to see it in the 3D view. We'll go back to the 3D view now. And now we'll see that because that layer is turned on, we can now use the layer and the textures to display. But we did just go through the trouble of creating our contours, so we can even turn off the surface and just turn the contour vector data on, which I think is pretty neat. You can directly see the contours that we just generated by digitizing and creating our grid file. If you want to change the colors that you're seeing on the surface, that's done in the plot window. You can select our contour map, check fill contours. We see it updates. And we could choose to turn the vector data on at the same time if we wanted. And then the last thing I wanted to show you is if you really wanted to come full circle, you can always export your 3D view as an image and send it to a client or maybe even a coworker just because you're proud of your work. Okay, and that ends the presentation portion. Do we have any more questions about anything we've covered so far today? How do you get the z-axis to point downward since this is bathymetry? So Surfer kind of always works in elevation rather than depth. So we would need to change these to negative values to, and then it would go downward instead of upwards. So if you're working in depth in Surfer, it does need to be a negative value to see it as negative. You could just use grid math to multiply this grid by -1 if we got this far and then you realized you do need depth to be negative in Surfer. You can just quickly fix that on the grid, or you could fix it on your data before you even get started. While you're entering the depths, enter them as negative rather than positive. Okay, the contour label is upside down in the 3D view. Can that be fixed? Yes, we can fix that. We can go back to the plot window, select our contour layer, and check the orient labels uphill option, and return to the 3D view, and we can see they are now no longer upside down. Okay, we have another question. When working on a large map, can I digitize sections of the map one at a time and then join them together? Some polylines would carry over the sections. Yes, that's a great question. You could vectorize chunks of your map and then overlay them all into one map, as we were doing in the contents window. We have all of these layers, these are all overlaid. When Surfer will use their coordinates to align them, so they would be placed next to each other as they should align. At that point, you could export out to create one big shape file or one big DXF file using file export like I showed earlier. Or you could create all of the grids and then use grid mosaic, which is found in the grids tab in the resize section, mosaic, to combine all your grids together. And which way you'd want to do that really depends on how large of a data set you have. If your data set is really, really big, you'd probably want to grid it in chunks so it would take less time to actually create the grids. So it'd just be a function of really how big that data set is. With really, really large data sets, gridding can take some time. Is it possible to export the grid in a format compatible with ARC? Yes, it is. If we go back to the Grid from Contours dialog, to save the grid as anything other than a GRD, click the Change File Name button. And then the Save As Grid dialog, choose any of the formats you'd like here. There are plenty of formats that are compatible with ARC, and really, I don't know of a software package that we can't communicate with at least one shared file format. So plenty of options here. All right, well, it looks like those are all the questions that have been sent in. If you happen to think of anything as the webinar concludes or you're typing something in, go ahead and send it. You're also welcome to reach out to us with questions whenever you'd like to surfersupport@goldensoftware.com. Otherwise, thank you so much for joining us today. We really appreciate you spending some time with us. Again, I will email each of you a link to the recording along with the data I used later this week. And thanks again. I hope you have a great day.